Hello, so we have here question number 4. Given the sequence defined by Bn is equal to n square divided by n plus 1 factorial, find B6. B6, that means n is equal to 6. So in the given expression, in place of n, you would write 6 divided by 6 plus 1 factorial. 6 square is 36 divided by 7 factorial. 36 divided by 7 factorial is 7 times 6 times 5, 4 times 3 times 2 times 1. Now we can see whatever divides 6 times 6 is 36 and 3 and 2 divides into 6. So we are left with 1 in the numerator. 7 times 5 times 4 will be 140, I think. So that is your answer. B6 would be 140. Now as we learned factorials, there's a lot of time factorials are used into sequence. Next we have summation notation. Given a sequence A1, A2, A3 and so on, nth partial sum Sn is a finite series represented by Sn, which is equal to sigma. It's written as sigma. This symbol is called sigma. It means sum. Okay, of ai, where I is the index of the summation, 1 is the lower limit of the index, n is the upper limit of the summation. So I is the counter. I keeps on changing. First I is 1, so a1. Then I becomes 2, a2. And then sigma means adding all of them. Sigma is this Greek symbol. It's spoken as word sigma, and sigma means sum. So sigma I from 1 to n ai means a1 plus a2 plus a3 and so on until an. That is a partial sum Sn. Sum of all the terms of the sequence in an infinite series is also can be written as summation. I from 1 to infinity. Infinity means infinite series. Add all of them. Ai, a1 plus a2 plus a3 and so on until infinity. So there is just a dash written. No final term is written. Write each of the series and evaluate the sum. So the first one here, let's say its first one is, let's name it part A. It says sigma k from 3 to 6 negative 1 raised to power k times 1 by k. Now when you plug in start from 3, that gives negative 1 raised to power 3 times 1 by 3. Then k becomes 4 and you add on the terms. So series meaning it's a sum, and sigma also means it's a sum. Negative 1 raised to power 4, 1 by 4 plus negative 1 raised to power 5, 1 by 5 plus negative 1 raised to power 6, 1 by 6. Negative 1 cube is odd number, so it's negative 1/3. Negative 1 raised to power 4 will be positive, so it will be 1/4. Negative 1 raised to power 5 will be negative, so 1 by 5. Negative 1 raised to power 6 is positive, so that is this. So that's a simple fractions adding, subtracting. You can do that, and that would give it to you negative 7 by 60. Let's try part B. We have sigma 2i plus 3, I from 1 to 5. So when we plug 1, we get 2 times 1 plus 3. That is when I is 1, plus for sigma, it's a summation. I becomes 2, 2 times 2 plus 3 plus 2 times 3 plus 3 plus 2 times 4 plus 3 plus 2 times 5 plus 3. That's 5 plus 7 plus 9 plus 11 plus 13. We can add them easily using calculator. 45 is your answer. Let's look at part C. We have sigma n from 1 to 6, 3. Now this one's a little different. Here it's only 3. It's not having any n, meaning when n is 1, it's just 3. When n is 2, it's just 3. So you're just adding 3 6 times because summation is from 1 to 6. That would be 6 times 3 and we will get 18. Write each sum using the summation notation. So when we have this kind of problem, we have to first say the general term. In this case, the general term is given as square root of n plus 2 divided by n factorial. So when I'm going to write this sum as a summation, I would write ai. So instead of n, I'm going to write I here. I plus 2 divided by I factorial. I is going from 1. The first index, first value here is 1. 2. The last value is n. So that is all they're asking. Write the given sequence, the summation of the sequence, which is called series, as a sigma notation. Let's try to work on part B. It's 2 by 1 minus 3 by 4 plus 4 by 9 minus 5 by 16 plus 6 by 25. First thing I observe, in this case, we are not given with the general term. So let's start writing the AI, the general term. Okay, now first thing I notice, this is alternating series. So there has to be negative 1 raised to power, either n or n plus 1. If it was n, the first term would be negative, but first term is positive. So it is n plus 1. Each term is a fraction. If you notice the denominators 1, 4, 9, 16, they are just square. 1 square, 2 square, 3 square, 4 square, 5 square. So I think in the denominator I have I square. Actually we're talking about I, so here we have to write I, not n. I square. Let's look at the denominator. Numerator here. In the numerator we have 2, which is 1 plus 1, 3, which is 2 plus 1, 4, 3 plus 1. So in general, I think the numerator is I plus 1. So that is my general term. And this, when you are adding all the terms, it is adding from 1 to 5. So this thing can be written as summation I from 1 to 5. The term is negative 1 raised to power I plus 1 times I plus 1 divided by I square. Now let's talk about some properties of summation. The one we already kind of did. If C is a real number, if you're adding C from I1 to n, just like adding C n number of times, so that will be C times n. It is adding a constant n number of times, that would be equal to Cn. If we have a sequence an and we are adding ca1 plus ca2, so this one is like you are adding ca1 plus ca2 and so on to can. So you can factor c out, a1 plus a2 plus so on to an. What is that? That is c times sigma I from 1 to n ai. So that means what we are saying, if it's a series CAI, you can take C, if a C is a constant, we can factor it out. Next we have sigma AI plus minus BI, sum or difference of two series. They can be separated like that. Sum of AI, summation plus minus summation of BI. So these were the properties. Let's see what we learned in this chapter. An infinite sequence is a function whose domain is set of positive integers or natural numbers. And dash is a sequence in which consecutive terms alternate in sign. That sequence is called alternating sequence. Number 3, A dash formula defines nth term of the sequence as function of one or more preceding terms. So that is called recursive formula. For n more than or equal to 1, the expression blank represents the product of first n positive integers, n times n minus 1 times n minus 2 and so on till 1. That would be called n factorial. Furthermore, by definition, 0 factorial is always equal to 1. Given summation sigma I from 1 to n ai, the variable I is called index of summation. 1 is called the lower limit of the index. Then the value n is called upper limit of the summation. One property of summation indicates if you are adding c, I from 1 to n, that is means like c adding n times, right? So that can be written as Cn.